Hey guys, welcome to my channel. And today I want to talk about cross origin resource sharing. This is a web protocol, an HTTP security specification that governs interaction between front end apps and back end apps. There is more detail to what kind of interactions those will be, but we're going to take a look at them in a few minutes. So I'm going to break down this tutorial into chapters, and in the first chapter, we're going to talk about the an overview of web applications. So I'm just going to scroll to the right and show a simple architectural diagram of what I think is a um, uh, basic architecture of a simple web application. And I think it represents core components of most web applications. So here on the left, we have backend part of our web application. It has API code and static files like CSS, HTML, images, and JavaScript. And then on this side, we have the front end part, which has the browser, the device storage, where the browser sort of caches and stores data that it needs. And then here we have third party services that scripts in the browser might call to get additional resources like fonts, images, and scripts, more CSS maybe from CDNs or and so on. So let's just talk about a little bit about how a typical request flows. So what I have here is a traditional MVC application. For those that may not know, MVC is an architectural pattern for web applications where the backend or there is one server that serves all resources needed for the application, both the API code and static files needed to display on the browser. So in this case, if a user comes to the browser and types a URL for the application, a URL for the server, then the browser will make a get call to that URL, and the server in response will send all the static files it has bundled up in that application. And when these reach the browser can optionally cache the static resources like the JavaScript, the CSS images, and so on. And then based on maybe particular fields or tags, like in the HTML tag, of whatever extra resources the server files need, the browser will also send requests to third party services like CDNs to fetch more scripts or CSS to be able to render a fully featured UI to the user. So when the user is on this page, they could typically do more operations like login, um, maybe perform actions after logging in. So I have shown these other two arrows to represent subsequent requests the user makes after the first contact. So these typically involve maybe clicks a button and some data is updated on the server and so on. And among the stored data, let's say the user, after receiving the first page, logs in, then the server will send back maybe cookie information, and the browser will store it in the device storage. And in subsequent requests, all modern browsers will typically attach session information when a script sends a request to the backend. So this is just a very brief overview of how web applications will typically work. So let's go to this side and take a look at another architecture. Here, only one thing has changed. Now, this is no longer an MVC application. This is like a single page application architecture where our front end resources are served from a different host and back end resources are served from a different host. So here we may have like a React application served from an Nginx server, uh, and the server is running on a different host, which may just be like a subdomain like app.example.com. and the server is like at api.example.com, or localhost port 3000, localhost port 8080. Common setup. So again, the user will this time type the URL for the web server serving the React application. And then the browser does the same thing. The server sends all the static resources, JavaScript, images, CSS, and all. And then the browser caches whatever it can cache that will not change between requests. And then typically a script there, maybe let's say user logs in, will send a request like in this arrow to the API, and the API responds, and maybe even the scripts will call third-party services. So what is happening here actually is that the script, whatever script that the browser downloaded, is making the page dynamic and is sending requests to update the page based on user actions. So this is a very important thing to note, that we separated the front end and the back end resources. So now, having said that, let's look at now a diagram that has both architectures side by side, and my little box here with key concepts I want us to take away. So in both architectures, the browser on the user's request calls the API or the web server, web backend, and the web backend sends static resources, JavaScript files, and all. And let's assume in each side there are scripts that are going to be downloaded and saved on the browser, and these scripts will then be used to respond to user action, maybe call the backend. And the cross origin data exchange part of my 3 points here means that, for example, in this part, we receive JavaScript from this API, this server, and we're able to make requests to third party services from within the browser just to perform some features of the application. And then on this side as well, apart from fetching from third party services, to when we make this request to this API server, it's like this is a third party request because the browser had downloaded the JavaScript from the web server running on a different host. And the script sent API request to our api.example.com. And according to this architecture, the API sees requests from that script, from scripts downloaded from that server, as coming from a different origin or a different host, just like the third party services saw requests coming from the browser as requests from different hosts. So this is the cross origin data exchange bit. You load the first page from a different host, and the JavaScript inside those static resources can make calls to other hosts to give the user a full featured functionality. So this is inherently risky. Hence, my third point here, which is security risks. We are concerned with scripts making cross origin data exchange requests. So, let's take an example. And remember, by the way, I said the browser stores some data in the device locally because the browser runs in the user's phone um, or, or computer. So, among the data stored locally here could be data that is maybe session cookies, because maybe the browser fetched the first page, the user logged in, the API server responded with a session cookie, and then the browser cached it locally. So browsers, by their nature, will attach that session cookie to every subsequent request the API, any script makes from theoretically. If a script makes a request to the API, the browser will attach the session cookies that this API had sent during maybe a login or other previous requests. So the fact that every request to the API server will include session information or cookie information adds the risky part of cross-origin data exchange, because then this user's browser, the user may be visiting different sites, and or just and those different sites download different scripts, or just the request that downloaded files from the third-party services could be a malicious script. And this malicious script will send a request to the API service. And theoretically, the fact that the browser will attach session cookies to that request means that any script that manages to send a request to the API is going to benefit from the session information that the browser attaches to every request going to that API. So if the script is a malicious script, then the API is going to be able to respond positively because the browser attached session information, and the malicious request will be able to perform some actions that we may not desire, maybe stealing user information or something like that. So based on this brief overview of how web applications work and the nuances that involve making cross-origin data exchange requests by scripts. I think we shall go to the next chapter and discuss another concept that will build on top of this knowledge to help us understand cross-origin resource sharing. Thank you.